Case number 7. Let's look for an identity which results from the operation here. We have the cotangent squared of y to be divided by the cosecant squared of y. We need to express both of them in simplest forms, say cosine y and sine y, or a combination of both. This is for us to be able to simplify it further. Now, do not worry about the exponents here, because these exponents will also be credited as soon as we transform them again in terms of cosine, sine, or a combination of both. We know that cotangent y is the ratio of cosine over sine. Okay, so our cotangent y is cosine of y over sine of y. But since the given is cotangent squared of y, we also going to add here square and square here. So cotangent squared y is equal to the ratio of cosine squared y and sine squared y. Now let's proceed to the cosecant squared y. The cosecant squared, or simply the cosecant y, is expressed as 1 over sine y, because cosecant y is the reciprocal of sine y. But then again, do not forget that the given is cosecant squared of y. This would mean that we're going to place square here and square as well. But since our numerator is just 1, so it stays as 1 because the square of 1 is just 1, and we shall simply add here square. This means that the cosecant squared y is sine squared of y. So these are just the first steps as we convert the cotangent and cosecant in terms of cosine and sine, and observing the exponent of 2 so that we will not be deviating from the given. Now from here, we can see that we are dividing two rational expressions, and let us use here the keep, change, flip method. The keep, change, flip method is used for dividing fractions and rational expressions just like this. It means that we keep the first term, or our numerator, so it stays cosine squared of y over sine squared of y. Instead of division, we'll have multiplication, and our denominator now will be flipped or reciprocated. So when we flip this, it would be sine squared of y over 1. So this is what happened when we do the keep, change, flip method. Now, before we proceed in multiplying numerators to numerators and denominators to denominators, we can see that we can cancel sine squared y here and here as well, because sine squared y is present in both numerators and denominators, leaving us a result which is just equal to the remaining numerator cosine squared y over 1, or simply write this as a final form, cosine squared y. This is now the identity equivalent to the ratio of cotangent squared y and cosecant squared y. It's cosine squared y over 1, or simply cosine squared y. This case for missing identity is now closed. If you may, to be ready for some new cases, subscribe now.